EUHubs4Data. The session is about how we're federating data resources to boost companies developing AI solutions. My name is Natalie Chernetska. I work at TerraLab IMT, where I'm head of business development, and EUHubs4Data project. We lead the work package, which is called Toolkit for Federated Services. And so I'm now going to introduce the session briefly and sort of the order of the speakers, and then we'll go into the presentations right away. So we are going to, the session will be constructed in the following way. We will start with the overview of the project and some of the challenging we're facing building this federated model of the organization, but also federating resources. And federation is really a key word in our project. And it will be presented by Guillermo Amat from ITI in Spain. ITI is the coordinator of this project. Then we are going to share experiences from a partner's point of view. We have multiple partners in the project, I think over 20 now, and Andrea Manzi and Levente Farkas from GIJ Foundation are going to speak about their experiences providing data resources and also working on different interoperability tasks. And then after partner experiences, we're moving towards companies, because one of the part of the project are experiments with those resources that we provide by real companies developing real world solutions. And we have three speakers. We have Kirill Blashko from Tunnel. We have Mauro Manente from Latitudo 40. And we have Andrei Kostin from Binare.io, who are all going to share their insights from participating in pilots of the project. If you have any questions to any of our speakers, you can put them in the chat, and at the end we are going to have a Q&A session for the entire Q&A session for the entire session. And the session is 1 hour, so we have a lot of ground to cover. So without further ado, I will introduce more in detail our first speaker, who is Guillermo Amat. Guillermo, please switch on your camera. And he is Director of Technology Support to R&D area at ITI, Instituto Tecnológico de Informática in Valencia. ITI coordinates the project. And for our project, he's also the technical manager. So he's extremely well positioned to explain to you both our federated model and also the technical challenges we are facing to build the catalog. So Guillermo, the floor is yours.
Okay, thank you, Natalie. I'm going to share my presentation. So, okay, now I'm sharing. So thank you very much, Natalie. As you said, I'm Guillermo Amat. I work for SGI. I'm the technical manager of EUHubs4Data project. And I want to introduce you and to explain you how we're implementing a federation model for the hubs participating in this project. First of all, I want to explain the main objectives and the challenge we have in the project. So, as you can see in this map, we are 21 hubs currently from different parts of Europe, and we are trying to create a federation of digital innovation hubs. And as I said, we are currently 21. At the beginning of the project, we were 12, and in the next year, we will join. There will be more hubs joining until the name of 30. As you can imagine, each one of these hubs have their own catalog of their own sets of services, data sets, and courses that are the kind of assets that we want to federate in this entity. So this is the main objective. We want to act as a single entity, which is a federation of hubs, and to achieve that, we have to create a common catalog of assets, and we want also to offer these assets to the SMEs, but giving them local support with a local presence of all the hubs. To that, we need to implement technology, but there are other considerations to take into account. There are ethical, legal considerations regarding the data that we are sharing, but also there are the concept of data sovereignty. That is also quite important. In this speech, I will focus mainly in the technological aspects. This is the final picture of what we want. This is the real federation working, connecting all the hubs within them, and this means technology. This means to implement interoperability from the technological point of view. After this, we will be really offering services, datasets, and whatever to the SMEs as a real federation of federated resources. So now I want to explain what we have done during the first year of the project, or our first steps. And the main idea was to implement this interoperability, and to do that, we needed to create a trusted environment to share that data. To do that, we thought that the best option was to adopt the standard proposed by the International Data Spaces Association and covered in the reference architecture model. In addition to that, in the project, we have 3 rounds of experiments where SMEs could apply. So we wanted to use this round of experiments to improve our implementation of interoperability and the ways that we are collaborating. To do that, we thought that the best option was to request to the applicants to select different services from different DIHs to force us to collaborate, to interoperate, and to combine these services or services with datasets from different hubs. So the idea was simple, just to create a catalog, to publish a catalog of assets, and then to implement this interoperability before starting the execution of the first round of experiments. And then we will use the second and third rounds to improve everything. So we did that. We published the catalog. We published the first version of the catalog, categorizing all our services or our data sets. And then we tried to implement the interoperability thing using the IDSSA components, in other words, following the reference architecture model from IDSSA. At the same time, we launched the first open call. We selected 10 experiments, and as you know, we will have 3 of them today explaining their experience later. These experiments are very interesting in terms that they are applying big data, machine learning and artificial intelligence to big data. And this is how these experiments are making us to collaborate. This circle, each column in this circle represents a hub of the federation, and you can see the lines how one hub is collaborating with another on because of an experiment. Okay. So we are not finished yet in this first round of experiments. We are month of 8 of 9, but we have some lessons learned currently. On the positive side, we have reached a high level of collaboration between hubs, but also between hubs and SMEs. Also, we are quite happy. We are proud of the list of services that we have been offering to the SMEs, because we are seeing how they are progressing in the experiments using these services, using our support, even our consultancy, and we are following these experiments and we are seeing how they are reaching their goals. But not everything is perfect. I said before that we were trying to implement interoperability before starting the execution of experiment, but that was impossible for us because the lack of knowledge of the reference architecture model and everything that involves the technology of the reference architecture model and the interoperability, and also because of the state of the components which were compliant with the IDSSA standards, because they were under continuous development, adding features day by day and increasing the version, and sometimes without having backwards compatibility. And this made it impossible for us to implement this technological aspect before starting the experiments. So what we are doing now is to continue with this work. We are also having the same objective to create a data space, a common data space, a data space of federated resources. And to achieve this and to reduce this technology gap, we are working on 3 main pillars. The first one is still the same, is implementing IDSSA components following the reference architecture model. The second one is to improve the catalog. Today we are starting the second open call of experiments. I will explain a little more later. And the third pillar is the service delivery framework, which is a component that we are developing. So regarding the first one, now we are using the version 6 of the data space connector, which we think is stable and usable. And indeed, we have a first testing scenario where 2 hubs are sharing data, one using different connectors on our sites. And the first objective in this area is to provide access to dataset using connectors. Regarding the catalog, we have published the second version of the catalog. We have improved the categorization, the data that we use to detail every single service or dataset. And in the future, we want to give some more features to the members of the federation to control even better what they are publishing in the catalog, to have control of what they have in the local catalog, what they are sharing with the federated version of the catalog. And also we want to have a tool to validate, especially datasets that could have some concern related to legal or ethical aspects. Finally, the service delivery framework is the component that we are developing, and is the one that will help us to share the metadata between the nodes of the federation. And we want to use this component to update the catalog, but also to update the items that are published in the data space connector. Currently, we have a proof of concept software that is able to communicate this metadata between different nodes. And that's all. I want to remind you to announce again that we are opening today the second open call of experiments. If you are an SME, I'm inviting you to check this URL that you have at the bottom. The open call will be open until February. We will have a webinar in 2 weeks, I think, and a second webinar in January explaining everything that you will need. And that's all from my side. Now I'm giving the floor to Andrea that is going to explain a little more about the use cases that we are implementing.
Thank you very much. Thank you very much, Guillermo. That was a very interesting introduction into the project, and I really like the way you emphasized the very iterative and collaborative nature of this project, and the fact that we are constantly reflecting and also acting upon lessons learned. And I think I really hope this is very useful for this project, but I also hope this will inspire other projects also to move in this cycle of continuous improvement. Thanks a lot. Now let's move on, because as I said, we have a very tight schedule, and we are going now to talk about experiences of a partner providing their services, of working on different activities, interoperability, data sharing in this project. And I'm going to give the floor. It's going to be a 2-man show. They're going to be Andrea Manzi and Levente Farkas. They both work at GIJ Foundation. And Andrea is a data solution manager. He is actually service owner of the GIJ data services. And in the project, he leads work package in charge of data sets. And Levente is a cloud solution architect technical solution team at GIJ Foundation. All right, so Andrea, Levente, the floor is yours.
So good morning, everyone. Thanks a lot, Natalie, for the introduction. So I'm going to describe a little bit the GIJ Foundation DH, the start, and then explaining a little bit what are the services that we are providing also in the context of EUHubs4Data. And then I will introduce one of the services that we are delivering as part of the federated catalog of the project, and how we implement interoperability, and we are trying to implement interoperability of this service using IDSSA Connector, as also mentioned by introduced by Guglielmo previously. So first of all, I will, and the second part, of course, will be covered by Levante, my colleague Levante. So basically, we have as GI's federation, the GI Federation is the international infrastructure that provides advanced computing and data analytics for research and innovation. And basically, it is governed and by a council of 26 countries and international organization, and the GIJ Foundation, where it's based in Amsterdam, and is the basically it's the organization, the non-profit organization, which is organizing the activities of the GI Federation. And the GI Foundation itself is BDAVA member since March 2019, and of course we are a member of the EUHubs4Data project. We have been so here I put a list of the different participants with the countries and the representative in the council. We are running since a couple of years also the Digital Innovation Hub. So the idea is of the Digital Innovation Hub is to help and support companies in the adoption and test and validation of computing technologies in order to become more competitive. And of course, we would like to have provide with the Digital Innovation Hub an open and innovative environment for experimentation, training, and networking. And on the other hand, we would like to open to innovation also to other GI Federation members by relationship with the business sector and with external company. The idea, as an example of different industrial relationship, we have of course relationship with typically with startups on SSME, which are of course benefit most for the piloting and proof of concept and consultancy, and also the visibility activities. But we also have like a connection with the larger entities. And of course, by participating also in project with the industry partners, like of course EUHubs4Data, but also others, we are reaching also other SMEs and industry partner. So the as I before, we have it's an international infrastructure for computing. So basically, the service catalog that we offer is mainly related to compute, storage, and data. So cloud, high throughput compute, but also data services for storage and for data transfer and data management, and others. And we also have like a specific expertise on service management, and also do delivery trainings on security and FITSM. And here highlighted the services that we are currently delivering and publishing in the catalog of the services in EUHubs4Data. And also mentioned by Guglielmo, we are participating in the first open call of the experiments with supporting like 2 SME that have been selected during the first project open call. One of the services that we are federating in the EUHubs4Data, it's the DataHub. Basically, this is one of the services that part of our portfolio, and it's based on One Data technology. And the main functionality of this service is that it allows the aggregating data providers, which are running this particular component, which is called One Provider. Basically, it offers functionality also of open data repository, so we can have like sharing the data for anonymous access, or also possibility to assign PIDs or DOIs. It also includes metadata index service, and in general is a platform for hybrid cloud data management and on-the processing environments, with offer also easy access via POSIX to different backends, which are provided, which are like abstracted over this software that we're installing. So the idea now is that, as before, we're working with IDS referent architecture in order to enable the federation of this service with the rest of the EUHubs4Data Federation. And I give the floor to Levante in order to explain how we are using IDS and the concept behind. Thanks a lot.
Good morning, everyone. If Andrea presented the EGI DataHub as a federated storage solution, I would like to talk about the challenges in making it part of the EUHubs4Data project. As you probably know, this project aims to establish a European federation of big data digital innovation hubs, providing a pan-European catalog of data sources and services, with the ambition of becoming a reference instrument for sustainable, data-driven cross-border experimentation and innovation. Well, with such ambitious goals, this project faces multiple challenges, of which I'd like to address the issue that small and medium-sized SMEs are not too well equipped to tackle the complex issues of data protection, data privacy, governance, even ethical concerns, nor are they able to extract reasonable value from their data. Two types of challenges I would like to cover specifically. First, the issue of lost value. Today is a common understanding that data is of high value, and leveraging this value and trading data creates huge revenue for large data platforms and providers or brokers. But the creators of the data are rarely benefiting from this value in an adequate way. Often, only the cost for data creation and management remains with the data producers. Furthermore, many give their data away for free or pay with it for the use of some service. And finally, others even keep it for themselves without taking advantage of the value. Then another category is the issue of privacy and security. Many organizations collect and store sensitive data for which there is an important, usually legal duty to protect the privacy of clients and consumers. For example, healthcare, insurance, banking, legal services, and so on. But before we look at how these challenges are addressed in EUHubs4Data, I would like to introduce the notion of data sovereignty. What is that? The ability of data providers of all types and sizes to self-determine what happens to their data and define how, when, and at what price others may use it represents data sovereignty. To help companies achieve data sovereignty, there is a need for vendor-independent data ecosystems and marketplaces open to all and at a low cost and with a low barrier of entry. Marketplaces must also offer a secure data ecosystem of trusted partners where data access policies can be enforced. The International Data Spaces Association developed a global standard that secures the exchange of data according to the exceptionally high security and privacy requirements demanded by European participants. This standard enables data sharing through data spaces characterized by uniform rules, certified data providers, and consumers. I will not insist too much on the IDSA standard architecture or ecosystem, as these will be probably covered in more depth by other sessions. However, I will just mention some benefits: data privacy and security, equal opportunity for participants, assurance of data sovereignty for the data owners, and last but not least, it is already a DIN spec, and it is going to be an ISO standard. A glance at the IDSA reference architecture, which is the materialization of the IDSA standard, and is built on the following principles. It serves as a practical blueprint, but also as an example of the ethical and design principles that will ensure trustworthiness in data exchange. It enables self-determination and control over data usage to remain in the hands of those who collect, store, and provide it, rather than passing it to others, as it is often the case today. It's open, agnostic with regard to technologies and domains, enabling comprehensive description of data assets and interoperability. And finally, it provides a framework for technically enforced agreements for data sharing in addition to existing legally binding contracts. And this is very important. Data spaces are where this secure data exchange can happen. In order for these to deliver on their value proposition, we need the right components. I will only touch on the most important ones. The link at the top of the page can provide details on the others. So the IDSSA connector, which will be used both on the connector and on the provider and the consumer side, is the central technical component for secure and trusted data exchange. This connector sends your data directly to the recipient in a trusted, certified data space. So the original data provider always maintains control over the data and sets the conditions for its use. The connectors can publish the description of their data, to a metadata broker, allowing consumers to look up available data in terms of, I don't know, content, structure, quality, actuality, and other attributes. The identity providers create, maintain, and validate identity information of and for IDSSA participants. And finally, the clearinghouse provides decentralized and auditable traceability of all transactions in case paid access is needed to data. As part of the European EUHubs4Data project participants will use IDSSA connectors to publish their data. EGI's implementation publishes data from EGI DataHub. Data in DataHub is organized in spaces, which is just a fancy name for folders and subfolders. EGI built an adapter app that sits between DataHub and an IDSSA connector. This adapter app can publish an entire DataHub space, so an entire root folder, to the IDS ecosystem. It does this by creating a new catalog for the DataHub space. Then it creates individual resources for each file from that space. And you can configure the usage policy. By default, it is free to use, but it can be used but show notification on use, use and log usage, use a number of times, use in a specific interval, use for a specific duration, and so on. It is completely automatic, which means that adding or removing files to the DataHub space will be reflected in the resource catalog published to the IDSSA connector. And last but not least, it is scalable, so it can accommodate any number of consumers. I just want to note that due to the hierarchical nature of the data in EGI DataHub, our implementation can easily be adapted to other backends that organize data in a similar way, like, for example, S3-like or compatible object storages. So let's summarize what we achieved. We added one additional way to access DataHub, the federated data storage solution for EGI. Any IDS compatible consumer can now access data from DataHub as long as they accept the usage policy set by the data owner, thus respecting data sovereignty. Data sets stored in DataHub can now be discovered programmatically with the help of IDS brokers and can also be included in the EUHubs4Data data catalog. And last but not least, our solution is an enabler, for example, for the binary OI experiment, whose data will be published from an EGI DataHub. And maybe a few words about future plans. Today, this adapter app has to be deployed and operated by the data owners outside of the EGI DataHub. But we are planning to make this an integrated feature of DataHub. Well, actually, of One Data, which is what's powering EGI DataHub. So thank you for your attention. If you have questions, we can address those later in the QA part.
Thank you very much, Andrea and Levent. It was very interesting, the presentation of a partner of EUHubs4Data project, your services you are offering, and also this deep dive into concrete implementation of IDSSA Connector, this data sharing value and its value for the companies. If you have questions to Andrea, to Livendi, to Guillermo as well, please don't forget to put them in the chat and we'll take them at the end of the session. Thanks a lot. So let's move on. So EGI is obviously one partner of EUHubs4Data. As Guillermo said, we have over 20 partners, now, and the second version of the catalog is live these very days as we are speaking. And I think now we aggregate, we federate more than 160 services. Now, that's sort of the offer side. But one of the beauty of this project that we also have the other side, the real use cases side. And the rest of the session, we are going to talk just about this. We are going to share experiences of 3 companies that participated in the first open call. The first open call of the project was launched, I think, last December, just 1 year ago. And the experiments of 10 selected companies started in June. So now they are in full swing, and we are going to have 3 of them speaking here. When the open call was launched, we had one criteria, among others, but one important criteria was that the companies select services from at least 2 different partners of the project and at least 2 services. And so many of them did much better and selected many more. So without further ado, I will introduce the first speaker among the companies who's going to share his experiences. It's Kirill Blashko. Kirill Blashko is the CEO of Tunnel. Tunnel is a company participating in an experiment, and what they do, they provide sustainable urban bus services for small towns which don't have budget nor capabilities for such infrastructure. So Kirill, the floor is yours.
Thank you very much, Natalie, for the introduction. Good morning, everyone. Nice to see so many participants here. I'll share my screen. I have a few slides to show about the usage of data in the experiment. Just a moment, please. All right. I hope it's being shared right now. So yes, we do help with the technology. We do help small towns to improve their situation with the urban mobility. And our project is a part of the EUHubs4Data first open call. We're past the middle stage already. We have completed large parts of the experiment. But first, I'll quickly introduce you to the problem. So the problems for many small towns, unlike the big cities, is that they don't have budgets. They have insufficient funds to subsidize high-quality public transportation. And therefore, the quality of transportation is very low. Sometimes you have to wait for half an hour or maybe 1 hour for a bus. The bus stops are located very inconveniently, and at the end, it's not just a transportation problem, it's a social mobility problem, which doesn't allow the residents of small towns to actually rely on the transportation system to get to work, to school, to get a new job, and do anything which their town provides. So with the we don't do the demand responsive transport as well. So we improve the existing traditional system with the fixed bus routes by replacing the regular schedule with navigating pedestrians. So what we do is the pedestrian navigation. And that requires quite a lot of data processing. And actually, that's one of the reasons why we're a part of the EUHubs4Data experiment. So the proposal to the passenger is that in their small town, they at least can get, with the tunnel service, at least they can get something within 15-20 minutes. They can get a bus and get there, get anywhere in their town to any location. And to provide that, to provide the promised service, we have to rely on a few data sets and on some pre-calculation and on some real-time calculation. So in this experiment, we brought one data set from the open, which is open to everyone, which is OpenStreetMap, and it has an open license. Anyone can use that. And one of the digital hubs helped us, providing us with the satellite data sets, satellite imagery from the Copernicus program. And there is also one partial data set. We call it partial because it covers just the UK. But it very well covers the small towns and the details about how they are organized. So as Natalie mentioned, we did actually choose several services from several hubs. So we work with three hubs, receiving services from all of them. Here we can actually be considered as, yes, one of the users of the interoperability that the previous speakers have talked about. So from our side, from the technical side, as a consumer of all these data services provided by the digital hubs, Tunnel is a cyber physical system, and it needs to rely on several data sources and several computational resources as well. So if we look closer at how it's organized, in a way, it is a cyber physical system that accepts as an input the data from the physical agents, which are smartphone apps and the buses and their locations, and does processing with the data that it has stored in the cloud. So there is obviously the input from the passengers. We use the infrastructure of the digital hubs, and of course we rely on the data sets. So as of now, so far, we have completed the first part of our experiment, allowing the simulation, the actual digital twin of a real town to work in the infrastructure and in the cloud, and serve as many orders as we instructed it to do. And it is very much close to the real passenger demand that could happen. So since it's quite short on time in terms of the presentation, I would just mention the most important part for the interoperability topic is that we used one digital hub for pre-calculating the routes, which can take quite a lot of time on even a powerful machine. We also used another digital hub, and we are continuing to use it for the storage of the calculated data. We are speaking about of tens of gigabytes per one deployment. We also use some data sets provided by the digital hubs to actually choose which data is interested in and valid and has a commercial value for us as a company. And then we actually use the other digital hub in the EUHubs4Data project to simulate the passenger requests. So the project is still going on, and we would say that we're extremely happy how it is being developed right now. This is all from my side. Thank you. I would be happy to answer questions later.
Thank you very much, Kirill, for these insights into the experiments, into the things you are building. It's fascinating that you're using services from 3 different companies to build something coherent and to solve such an issue as urban mobility, which affects many of us, obviously living in small towns, but obviously on the outskirts of bigger towns, there are also no man land when you wait for a bus for a very long time. Thanks a lot.
Thank you.
Now, let's move. Thanks a lot. And obviously, if you have questions for Kirill and want to learn more, please put it in the chat, and we'll discuss it at the end of the session. Now, let's move to our next speaker, who is Mauro Manente. Mauro Manente is CTO and co-founder of a company called Latitudo 40, and the company provides a fast and easy cloud platform to access data extracted from satellite images. So the experiment within EUHubs4Data is also related to urban living, but perhaps more towards urban environment. So Mauro, please go ahead. The floor is yours.
Thank you, Natalie. Going to share my screen. Thank you, everyone. I'm Maro Manente. As Natalie said, I'm the CTO of Latitude 40. What we do in Latitude 40 and how we are involved in the EU hub for data. What we created in Latitude 40 is only one urban data analytics platform for climate action planning that is based on Earth observation data. So satellite images, and not only obviously satellite images. And why we created this platform. Basically, the problem is related to climate changes. And obviously, cities are extremely vulnerable to these factors, to pollution, flooding, extreme heat. The climate change will be also a cost for cities, for all cities, and also under a real estate perspective. So what we did is understanding that the data that we can use from everywhere, but specifically from the space, are at the heart of the climate action plan for cities. So the question is where to find the data, how to automatically process them, also without any specific knowledge about the vertical information that are in the data, how the data should be kept up to date, and how, basing on this data, we can simulate the future, also because some solution for the climate action plan will not bring an immediate result on the climate response. And last but not least, how to finance this strategy. So the idea is creating a solution that is able to collect information not only from satellite images, but mainly from satellite images, also because this allows us to see the world from above, and is a privileged point of view to see what happened. Also having the chance to look at the past, because satellite, with a difference with the common IoT sensors, has the chance to look in the past, because images are archived since several years. Obviously, the opportunity is to mix the information that we are able to extract from satellite images using artificial intelligence from data that we can collect from several and different and heterogeneous sources in order to create a positive solution to climate changes in action plan, related to action plan. This is basically the reason why we applied to the open call. As I said, our solution is based on data from different sources and from heterogeneous sources, and we aim to apply our algorithms of artificial intelligence and also to create geospatial analytics in our infrastructure. So this is the opportunity that the open call gave us in order to aim to get some targets. The first one is to validate our product, some of our concepts, and doing this also with the stakeholders and also with the cities. Obviously, with the help of experts from the IHs, and last but not least, obviously using federated resources not only for I mean, collecting data, because obviously we are able to collect the data from several sources, but having a federated infrastructure that allows us to collect the data from different cities or different sources in a, let me say, standard way, allow us also to use the federated resources as a way to share the actionable insights that we are able to provide. Our experiment, as I said, obviously starts on the chance to work on satellite images and use open data and also commercial private data from IoT sensors or from other sources, basically to achieve two goals. The one is create a urban entitlement mitigation index. This means that every city will be able to understand if their actions to fight the urban entitlement phenomenon that affects several cities all around the world are efficient and are going to reach the right result in also not in only in the short period, but also before the action will be implemented. They can see on a medium and long period if the action changing the pavement or planting trees or have a greenery quality increased will be the right solution, also to blend the cost. The other one is to create a quality of life index under an environmental point of view, because obviously this means that everyone is able to understand if what's going on the city under a climate action plan interventions is going to increase the quality of life of citizens, but obviously indirectly from the environmental quality of green areas, parks, and so on. We are working with the IHH Aragon and EROCAT, and we are honored to work with them. And as I said, we had the chance to work with Barcelona, that is going. It's our testbed for the experiment, and this is a real good opportunity for us to prove our concept and to use a federated infrastructure to get data and share actionable insights on climate actions. This is all for me. Thank you so much.
Thank you very much, Mauro, for this presentation and for explaining what you're doing. I really liked what you said, that your data is the heart of developing climate action plans, and how you are building different data analytics systems to help cities to face those climate changes. And obviously the way that how you explain that one of the beauty of working in with EUHubs4Data is that definitely you have access to federated resources of multiple partners. So we are looking forward to continue of your experiment, sort of learning more how City of Barcelona develops this pilot. Thanks a lot.
Thank you, dear.
And now we are moving to our next speaker, who is Andrei Kostin. So Andrei is a CEO and co-founder of a company called Binare.io, which is a deep tech cybersecurity spin-off from University of Jyväskylä in Finland. And they are in the field of IoT cybersecurity, another extremely important issue. So Andrei, go ahead, the floor is yours.
Thank you so much, Natalie. Thanks, everyone. I'm very happy and thrilled to be presenting our project. Let me just start sharing the screen, and I hope it can be seen. Just let me know if it doesn't show up, but I assume it works okay. So my name is Andrei Kostin, and I am the CEO at Binare.io. And as Natalie said it, we are focusing on IoT cybersecurity, where we develop automated solutions and deep tech services and technologies. So very briefly about Binare, we are research and development and innovation tech spin-off from University of Jyväskylä, Central Finland. And we've been founded in mid-2020 with headquarters in Jyväskylä, and currently we have a team size of 8 and growing. As part of this growth, we are on a mission to help secure the next billion of IoT devices globally. We develop mainly software as a service, deep tech platform, which are patent pending and cater to multiple types of organizations and businesses. And the main reason is that we want to help them secure the IoT devices that are in their networks, whether it's enterprise networks, government networks, or home networks. And the idea is that in order to do so, the IoT devices need to be secure. And the main idea is that in every IoT device, whether it's a smart TV, a smart car, router, printer, VoIP phone, whatever is a computer but doesn't look like one, they run software, often called firmware. And many times those softwares, they are in binary code, in binary form. So they run binary. And this binary is more like a compiled, very optimized, compiled way of running the program. And many times it's just a black box because it contains so many unknowns, so many hidden traps, hidden passwords or access. It can contain vulnerabilities which are not trivial to see even for experts with a naked eye. So Binare tries to focus on analyzing the firmware and software that goes into IoT devices. And we are here. And many times these technologies are overlooked because many times the IoT devices are looked either from, okay, they are already in the network and they are operational. So let's monitor if they get hacked. We will replace and fix them, but usually it's too late. And other times they are looked from the source code perspective. But again, source code is not what runs on IoT devices or on any computer system for that reason. Actually, it's the binary code that most of the time runs. So in order to try to secure this ecosystem of billions of devices, we need to understand what's inside the binary. But I'll get to that point towards third part of my presentation. So why we chose the EUHubs4Data open call. First, I think there was a very good and inviting mix of services being offered in the sense that it covered Binare's main needs, such as business development needs, the infrastructure needs provided, for example, by EGI and as mentioned by Andrea and Levente. And also the expertise in terms of big data and AI and machine learning, for example, CEDAR. I'll mention all our service providers later. And of course, at the same time, Binare was envisioning to actually produce data sets that I'll shortly introduce that are used as core fundamental data sets for bootstrapping cybersecurity for billions of IoT devices. In order to secure billions of IoT devices, big data sets are certainly needed, and they need to be able to be machine readable and also accessible through, for example, federated data, as Andrea and Levente mentioned. So what we do in CESOD, IoT CESOD project is IoT security software datasets, where we run our leading closed platform in a closed loop system experiment and produce cybersecurity datasets. And these are actually datasets mapped to firmware, SBOM, and vulnerabilities. These are quite technical terms. I'll try to explain them in the following slides. But the idea is, should have our system be used or data being available beforehand, such examples of when Vodafone discovered Huawei backdoors in their equipment and firmware could have been avoided, or at least found much earlier than they happened. It was a huge scandal, and it went to even diplomatic tensions between the US and China. So you see that technology even affects the diplomacy. So insecure, vulnerable IoT, binary firmware, and third-party supply chain is an issue for IoT cybersecurity all over the world. I want to explain why it's needed to produce this from the binary back a machine-readable dataset. Look at the food labels as well-known references. When we want to buy something, we look at food labels. We want to know their nutritional facts, their ingredients, where they produced, what kind of other chemical elements that might bring health issues, and you make an informed decision. Can I buy it? Should I buy it? Is it safe or healthy for me to eat this particular product? So this we take for granted. However, for cybersecurity devices that we plug to our networks, this is, you can think about your digital health. Your home network is your digital health. And the idea is that when you plug such a router, it's a black box. You don't know what you're plugging to your digital health network. And the idea is that we want to help take off this black box out of these devices and make them more transparent by providing these data sets where we map the software and firmware to their vulnerabilities and their potential risks to your network and infrastructure. And this is how, for example, our cybersecurity data label for IoT devices may look like, where you have an informed decision-making process when you buy something and plug to your network. And this is one of the testimonials that we get from a senior vice president of smartphone and smart home solutions in Europe, that thanks to our report, they have been able to address the reported cybersecurity issues internally. And that's a very strong testament that our technology and experiment in EUHubs4Data works and is useful for securing the next generation of devices. We are extremely happy to benefit. I'm sorry I'm taking a little bit more time, but we have business expertise from Know Center, the technology expertise from CEDAR, and technical infrastructure from EGI, which is tremendously valuable resources for us, because it's a perfect mix for us to make the experiment successful and reach our KPIs and key hours and goals. And to conclude, what EUHubs4Data gave us through IoTSSO is we already found a handful of vulnerabilities. We analyzed thousands and thousands of firmwares, and we processed gigabytes of data. And what future holds from this experiment onward is 50 billions of IoT devices coming, and there will be 50 billions of both security issues, but also growth opportunities. And we at Binary aim to help secure at least 1 billion of them in the years to come. So if you're ready to solve these billions of IoT cybersecurity problems, please don't hesitate to contact me at CEO@binary.io, and I would be happy to answer any of your questions about the data or experiments. Thank you so much, Natalie, and everyone.
Thank you very much, Andrei, for this insight into cybersecurity world and how you are using data to solve vulnerabilities in IoT firmware, which are multiple, billions of devices, as we understand. And I particularly like that you focused on benefits that Binary is drawing from joining EUHubs4Data experiments. Thanks a lot for all of our speakers. Our session is sort of closing to the end. I would like to ask that if you have any questions, please put them in the chat. Meanwhile, I would also like to remind you that these were 3 testimonials from the participants of our first open call. We had 10 partners providing services, and today we are launching our new catalog and our new open call, and the number of services, I think, almost doubled. I think we have over 100 services now, and the number of partners are obviously doubled. So perhaps as a final question, I would like to ask our 3 representatives from the companies. So you applied for the first open call 1 year ago. Now you are in the experiment phase. What you would say to the applicants now? What kind of your main lessons learned? What you would say to encourage them to apply for the new open calls and to benefit from those services? I will probably start in the same order we spoke. I will start with Kirill, then Mauro, and then Andrei. Kirill, go ahead.
Yeah, thanks a lot, Natalie. Great question. Probably my answer would be not exactly related to the technical issues, to big data, to the technology, to AI, to interoperability, but in a more general way, we would advise to plan ahead. So the project EUHubs4Data itself, it provides a wealth of opportunities to get support from the digital hubs, to get support with the infrastructure, to get virtual machines, real machines, whatnot, for any type of data experiment. But what is really important is that it's very much valuable if the experiment and the application planned has some realistic KPI. So the simple advice to the new applicants would be something like design your experiment in advance. Think about it something in a way, maybe in a more simplistic way, but in a way that is achievable. Something that can be delivered within 9-10 months. Something like could be said about, okay, we're going to build this kind of small tech experiment on this kind of equipment, or this cloud provided storage, or cloud provided computation, or some other federated sources, and then just run. So in this case, we could say simpler is better. So that would be the advice.
Thank you very much, Kirill. So we have very few time left. So Mauro and Andrei, quickly, please, and then we're closing.
Yeah, I totally agree with Kirill. It's probably the most important thing. Just plan the experiment before applying. Have in mind how to measure your results before applying, and then things will be in the best way.
Thanks a lot, Mauro. Andrei?
Yes, I would certainly agree with Mauro and Kirill. Kirill's points very on target, and I would also add that it's highly advisable. There are plenty of excellent expertise in DHSs. I would tell not to underestimate the potential of their help, and actually try to find those 2-3 services that together will make your experiment and your KPIs reachable, and the results being delivered even beyond what you've planned originally. So I think there's a lot of possibility to mix and match these services and teams for a fantastic result, in my opinion.
Thank you very much. Thank you very much, Kirill. Thank you very much, Mauro. Thank you very much, Andrei. So we obviously continue working together with you to bring your experiments to fruition. All my speakers, thank you very much. Also to Andrea and Levendi, thank you very much, Guillermo. Unfortunately, I mean, I would have enjoyed speaking spending more time and discussing more issues, but I hope we are continuing and will have opportunity to meet. Thank you for the audience for this attendance, and I'm closing the session. It was a huge pleasure to be here. I hope you learned a lot. I learned certainly a lot. And goodbye. Enjoy the rest of your European Big Data Value Forum. Thanks a lot, and bye-bye.